we are coming to the last 4 questions in terms of solving for logarithmic equation. Okay? Now, take a look at part A. There's no way I can change the base to any other form. This is a base 2, this is a base 3. Okay? And I cannot make use of any substitution method to actually solve. So the only last method that we can adopt is actually make use of taking ln on both sides or taking logarithm on both sides. Okay? You can use LG log, but I choose to use ln because it's easier to write. Take ln on both sides. Bring down the power term. Please remember to write in bracket. And take note, do not press the calculator for your ln nor your logarithmic value until you have expressed everything in terms of x. Okay, what you notice, there is an x term over here, there is another x term over here. The only way to take out a singular x term is to factorize the term itself. After that, final step. Then you will make use of your calculator to evaluate what is the answer over here for x itself. Okay? With the use of the calculator, very quickly, I will have 5.42. Tell yourself, if you need to solve a particular equation, but you cannot use substitution method, there's no way you can factorize, there's no way you can simplify, this is the only other method, taking ln or log on both sides. Okay, next, we're going to tackle 3 log question very quickly. Now, the way to actually approach solving of logarithmic equation is to make sure you have it always in log terms on one side. But we are very fortunate for this particular question. Why do we say so? If you take a look at this question, I can bring up my constant 3 as a power term for the main term for this log. And if there is a log term on the left side, there is a single log term on the right side, I can just compare the main term provided the base term are the same. These are both LG log to base 10. So, x plus 2 cubed must be equal to 27. So, if I were to cube on both sides, x plus 2 must be equal to 3. X in this case must be equal to 2. Please always check your answer. Please make sure when you substitute your answer inside, the main term cannot be negative value. Neither can the base term be of negative value as well. This is something you need to be mindful of. Okay? This is a test of concept, but the next 2 questions are more evident in most exam papers. Let us take a look at part C. Okay? Like I said before, we will always like to make sure there is a single log term on each side. But if we can't, the easiest way is to make all the log term on the left hand side, only the constant number on the right hand side of the equation, which is what I'm going to do now. And what do you notice? Alright, this is subtraction of 2 log terms to base 4. I can simplify into a singular log term to base 4. The first main term divided by the second main term is equal to negative 3. Okay, now we are ready to change from logarithmic form to index notation. 4 to the power of negative 3. Alright? As you understand in indices, 4 to the power of negative 3 is the same as 1 over 4 to the power of 3 itself. Okay? Press the calculator. I will have 1 over 64. Then I will do my necessary cross multiplication. What do I do next? Alright, if you don't find it convenient for you to do your normal factorization, alright, you can actually use your quadratic equation inside the calculator. Alright? So very quickly, I'll use my quadratic equation. -1, -2. Okay, I have decimal numbers. Okay, that is why please make use of your quadratic equation formula, because I sense this is very difficult to factorize, and the result shows that y is equal to 0.18476, or y is equal to -0.16914. Now, the thing now is you have to check whether your results are valid. Substitute inside. Alright? The main term is still positive. Substitute inside. The main term is still positive. Then, we can agree on this answer. Alright? Same thing. Substitute inside here. If your answers are still positive, then you can make use of the answer. But take note, -0.16 means log of negative value over here to base 4 cannot be done, because you can't log a negative value without using the square term over here. So this is empty. Alright? Because you can always put the 2 down, you still need to log a negative value without squaring the number here. So you will need to reject this answer over here. So always check your final answer. Make sure the main term can't be negative value, the base term can't be negative value. Last but not least, the last example. One good glance at the question, what do you notice? This base term is 5. This base term is x. For such question where the base are not the same, as much as possible, we try to change it to the number base. Okay? When there are a lot of base, change to the one that has the smallest value. Okay? When there is an unknown and a number, change to the one that has a number if possible. Even if you do it the other way around, there is nothing wrong. Okay? So I like to change it to base 5. Remember to write a bracket. I'm changing my base down to base 5. Log 5 to base 5 is equal to 1. You have learned that before. 4 multiplied by 1 is 4. Now I'm stuck. Why do I say that? There is a log x to base 5, there is a log x to base 5 at the numerator as well as the denominator. When you are stuck, you don't want to do any multiplication because it's going to do more complication to the question. The best approach is to do substitution method. You are right. Okay? With that, I would like to multiply everything throughout by 8. Do your normal factorization so that you can solve for zero product. You realize the value of A is either 4 or 1. Replace it. I need to find the value of x from logarithmic form, change back to index notation. Main term say, base term 5 to the power of 4, value 625. Similarly, main term say 5 to the power negative 1, answer 5 to the power negative 1, which is 1/5 itself.